Hello guys, this week we will continue the time value of money, and part 2 we already seen um, how we are gonna calculate from present value to future value and present value to annual series value. Then we can convert that annual series value to future or present value, or we can convert future value to present value or annual series values, and we convert it to each other. Right now we are gonna go through part 2, which is we will choose if we have not uniformly distributed, if we have gradiently increased series of money, if we have in this condition, how we are gonna approach and how we are gonna calculate this kind of process. So it's called uniform gradient cash flow, and we have two kinds of it. One of them is the arithmetic gradient, the other one is geometric gradient. Let's define all these two gradient cash flow, and we can represent it as mathematical formula. We can go through the questions and then we will understand all this, the value of money uh, during this week. The first one is arithmetic gradient. It frequently happens that the cash flow series is not of constant amount of A, which is like if we have a cash flow and from 0, 1, 2, 3, 4, and 5. Let's say we have 5 years, and we know that if we have series of uniform series, so we show in the same level of A, let's say like H, like A, 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 and we can define it as this guy, uniform cash flow, right? Annual uniform cash flow, and we can say like each term is 100 or 120, 125. This is normal, but in arithmetic terms, instead there is a uniformly increased series as shown. Like let's show it. It's gonna be, let's say 0, 1, 2, 3, 4, and 5. And like the first year, let's say we have A. The second one is gonna be like some sort of money increase, like A plus like some $10. Like if it is 100, it's gonna be 110, 120, 130, and it's gonna be 140. So it's arithmetically increased. So each term is gonna be like A plus, let's say G, A plus G, 2G, right? 1G here, 2G here, 3G here, 4G here, and 5G here. So if it is like 110 over here, 120, 130, 140, and 150, let's say, is increased. And but normally what we are saying is, let's go back. So we start from here as A, and we divide it into A terms here. So it's gonna be A the first year, second year, third year, fourth year, and fifth year. Then the increase. So at the first year there is no 0. So as an arithmetic gradient, the 0th year is here. Then the first year there is nothing as well. The second year is gonna be G term, and there is 2G and 3G. So 2, 3, 4, and if we 0, 5. So there's G, 2G, 3G, and the fifth one is 5G, no 4G, sorry. So this is how a diagram, like schematic way of show how this arithmetic gradient occurs in cash flow. Let's go to mathematical representation and maybe we can understand better. And then when we solve the questions, we are gonna show the also these cash flow diagrams. So it will be better to understand in this way. As I show the present value, if we want to take the present value of, like let's say again in terms like 0, 1, 2, 3, 4, let's say 4 years, and is arithmetically increase, and we say that instead of doing this, guys, we know that how we can calculate the annual series. So we divide it into annual series and G points. So it's gonna be A, again A plus the let's say here the 0, here the 1, 2, 3, 4, and when we have 0 here 1, then when we 2 second year we have G term, then 2G for the third year, and then 3G at the fourth year. So we said, okay, let's calculate it. These terms, let's divide it into annual series, which we saw last lecture, how to calculate this annual series. Hold on a second. All right, so we can separate it into two parts and we can calculate it. In this tabular form, I'm gonna show you in tabular form how we are gonna calculate it in this class. And in mathematical like manipulation, by using this G, which is arithmetic increase value, let's say here, if we A is 100, and then as we said, like 100, 110, 120, 140, 30. So we know that increase in $10 in each year. So we can say, okay, this arithmetic increase is G is $10 and annual series is $100. Then we will apply in these conditions, like how much interest rate the question gives and then how much year it's gonna take. We are gonna just like submit, and then we can calculate it in tabular form, and also we can calculate it for the future to gradient series. If the gradient series is given, we can calculate the future amount. If present value is given, we can calculate again by using G values, which is arithmetic increase. And also like like everything, like when you manipulate this one, you can in the compact version you just use this formula, and then you can convert these G values, which is arithmetic increase, all of them into present value. And then last lecture we know that the annual series, then we will convert it in the again present value. When we add each other, we will find the total present values of this segment, or any questions is asking with the arithmetic gradient increased. I show that the present values and let's go back. The future values, how to convert the arithmetic gradient with given interest rate and time duration, how we convert the future value and present value. Right now, we can see here the annual series value. So if you have the arithmetic increase, so we convert it in this version, which is we are gonna use here as present value. If you multiply present value with this guy, we know that we can convert it to an annual gradient. And if you manipulate this mathematical formula, we will end up with the final version of annual series value is equal to arithmetic gradient in the parentheses of 1 plus I power of n minus in minus 1 over the total of over interest rate multiplied by 1 plus interest rate power of n minus interest rate is gonna give us the annual series. If we go back behind, so we said that if we want to calculate the present value, we can use a, and then we have the g values, right, in this term. But if we want to take the we separate it. If we want to use a, just find an a with the given g, just need to plug this mathematical representation, and we will find our annual series formula, and we will be done. So if you have the present value and arithmetic gradient, sorry, if we have an a value, arithmetic given value, and if you want to represent in the same format as a and a, so you just need to cancel this one. You just need to add these a values into this guy, so you can convert it. You will multiply this coefficient and you will find the present value. And again, we will see all these by the examples. Okay, let's see the example. A person purchased a new car. He wishes to set aside enough money in a bank account to pay the maintenance for the first 5 years. The maintenance cost is as follows, which is the first year is 120, then 150, then 180, 210, and 240. When you see this one, maybe we need to write down a cash flow diagram, which is when you buy the car, it doesn't cost any maintenance. So after the first year, when he used the first year, he needs to pay, and the second year he needs to pay, third year he needs to pay, and fourth year he needs to pay, and fifth year, at the end of fifth year, he needs to pay. And is all of them is increased year by year. So let's draw these terms, and we can say it starts with 120, then it goes to 150, then 180, 210, and 240. It's very easy to see that it can be also described by 1, 2, 3, 4, and 5. As an annual series, it's gonna be each year he pay 120, 120, 120, right? After the first year, you spent 120 and 120. Plus, after the first year, 0, 1, and when he comes to second year, he pay extra $30. So it's 30 here, then 3, 4, 5. Then he pay extra 60 here. He pay at the fourth year and $90. And then the last one is $120 higher than the first year payment. So it means our A value is 120. Let's take this A value 120, and G values, which is arithmetic increase values, is 30, because it's gonna be 30 G, 2G, 3G, 4G, and increase arithmetically year by year. So we took these two guys, and let's solve the questions with using the previous formulas. Okay, let's solve this question. So we have p values that it's can be the present value can be represented by the annual series value and gradient increase value, right? So we said that our A value is 120 and G value is $30. And we need to solve this term and this term. How we are gonna solve? We know that from our previous lecture, present value is the it can be represented by mathematically a multiplied by 1 plus I power of the number of duration minus 1 over interest rate multiplied by 1 plus interest rate power of number of duration. And recently we learned in this class, if we have the arithmetic increase, we can convert this term into the present value. So if I add these two present value, then I will find the total present value. Let's see, like what is I. We will see what is I, and which is interest rate, and N is already given 5 years, right? It's already given 5 years. So let me check what is interest rate. Okay, the interest rate is 5%. We need to take. All right, just what we need to do in order to find the first parameter and second parameter, like the first value, we need to use this formula. So is, let's say, P1 is equal to, which is A is 120 multiplied by 1 plus parenthesis of 0.05, which is 5%, power of 5 years, minus 1 over 0.05 multiply 1 plus 0.05 is 1.05 power of 5, and we need to find this result. And for here, P2 is equal to G is 30, then we need to multiply it. 1 plus 0.05 is 1.05 power of 5 minus 0.05 multiplied by 5, which is 0.5, minus 1 over 0.05 square and 1 plus 1.05 power of 5. And we just need to find these two values, and we will add each other, and then we will find the present value. Let me calculate and come back. Okay, okay, let's continue with the calculations. For the P1 is 120 multiplied by 1.05 power of 5. Let's put in parentheses, and we need to do another parenthesis, yeah, for the division. So 1.05 power of 5 minus 1, right? Minus 1 over, again, let's open another parenthesis because it's gonna be 0.05 multiplied by 1.05 power of 5. 0.05 multiplied by 1.05 power of 5. Okay, let's close the first parenthesis for the division, second parenthesis for the here 1, 2, so 1 we close here, the second one is gonna be here, the third one is gonna be here. It's gonna be 1727. Okay, it's gonna be $1,727, right? So it's gonna be a minus term here. Why it's minus? Where did we make wrong? 120 multiplied by 1.5 power of 5. Oh, okay. Because here we will multiply by and then subtract it. So let's go back to here. So these guys is gonna be all together. So let's make it in this term. Yeah, 1.05 power of 5 minus 1 over these terms. So it's better in this term. Okay, 519.5. So this 519.54 for this term. Okay, $519.54. Okay, P1 term we already find. Let's see the P2 term, which is, let's go back to our term is 30 multiplied by, again, let's open one parenthesis. So it's gonna be 1.05 power of 5. Okay, let's make another parenthesis. 1.05 power of 5 minus 0.05 multiplied by 5 is going to be 0.25. 0.25 minus, it was, I think, 1. Yeah, 1. So I close the parenthesis and I made a division, which is 0.05 square, 0.05 square, and also let's make this one in parentheses, multiplied by 1.05 power of 5. Let's close this parenthesis and let's close another parenthesis. So it's gonna be 247.11. 247. This guys is 247.11. So altogether, the present value, total present value is P1 plus P1, P2, right? So it's gonna be 519.54. add with this one plus 519.54. So yeah, 766.65. 766.65 dollars is our present value. So the question was asking like how much money this guy need to put for covering for this 5-year maintenance. So it's gonna be 766.65 dollars he needs to put in order to cover all this payment. Okay, let's make our job a little bit easier because there are too much mathematical calculations here. If we get more further, our problems is gonna be a little bit complex. So in order to avoid this complex mathematical terms and then it will lead us erroneous answer due to typo or miscalculations or like some parenthesis error. So that's why we can make it a little bit our job easier. So let me copy this term and let's bring here. Okay, these guys. Okay. Let's delete this guy, this guy. All right. So I will use a tabular form in order to find these guys. Okay. As again, my annual value is 120 and G value is 30. I is 5% and N is 5 years. So if I use these terms, can I calculate B with A multiplied by some coefficient or G multiplied by some coefficient? It means the answer is yes. Where we are gonna take these coefficients is given by our course book, which is Newman, Essenbach, and Laville 11th edition of engineering economy. So in this book we will see, okay, what we need to look for is gonna be, as you see, there's a number of durations, the number of years, and which terms you want to use, f over p, p over f, or a over f, or a over p, f over a, and p over a, blah 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 blah. Let's go back our whiteboard, and as you see, I was showing you guys previously, if you want to find the present value, I want to use the p over a because a cancel with a and it will start with the p, and I'm gonna have the answer of present value. G cancel with g is gonna give again on top p. So p over a value or p over g value. Let's go back again our textbook. Where I need to look p over a and p over g, right? These two values. But which year? 5 years. But which percentage? 5. So it's not, this is 9. So I need to go up till I catch up 5%. So it is here, 5%. 5% and 5 years, where I need to look p over a and p over g. So I need to multiply 120 by 4.329 and plus 30 multiplied by 8.237, right? Okay, let's go back and then let's write it down. Here is P is 120, which is A, multiplied by P over A, I, which is 5% and 5 years. Again, let's go back to textbook. It's giving me 4.329, 4.329 plus $30. I need to multiply P over G, I, N. Again, let's go back to our textbook, which is 8.237, 8.237, 8.237. So when you multiply these guys, you will easily get again what is our answer was $766. Oh, it's approximately $766. Just multiply and then you will see we will have the same answer. As you see in this form, it's gonna be very easy and then very neat calculations, but we are learning the theory as well. So in the test, I may ask you either tabular form or the mathematical form. So you guys need to know both sides. All right. So maybe like these guys, this tabular form is gonna be your cross check. Our second term is geometric gradient. The percentage or rate is constant here rather than the amount of the change. So here, instead of like $10 increase like 120, 130, 140, it is the percentage is gonna change, like 10% change every year. For example, if the maintenance cost is $100 for the first year and it increases at a uniform rate of the small g is 10% per year, the cash flow is gonna be look like the first year 100, the second year is 100, 10%, which is 110. Then the third year is gonna be 110% addition, which is 121. Then it's gonna be again 10% of the third year, which is 121 plus 121's 10% is gonna be 133.1, and when you increase the 10%, it's gonna be end of 146.41, which in arithmetic one is gonna be 100, 110, 120, 130, and 140. So geometric gradient is slightly different than arithmetic increase, and we have, of course, different mathematical representation. Let's check it out. So we need to know the again annual series. After that, we need to add in this mathematical representation the geometrical increase, and we can find the present value. With this present value, we can find it the future values and annual series in uniform the annual series. So but in this one, the interest rate shouldn't be equal to geometric increase. If it is same, so we need to use this formula, which is P is equal to A multiplied by N multiplied by 1 plus I minus 1 is gonna be our mathematical formula for geometric series calculations. Okay, let's solve example for the geometric increase. First year maintenance is again $100 and it increases with uniform rate 10% per year. Using an 8% interest rate, calculate the present worth of the cost for the first 5 years. As we show the cash flow diagrams from 0, 1 to 5, right? So it's gonna be 100, 110, and it's gonna be increased 146 point something. So it's the same cash flow. We decrease it into again A values, which is $100, right? Is the for the first year is $100, and then after that increase. So G values after this guy, which is G, is 10%, which is 0.1, and we will use the present value formulation and we will solve this example. Let's solve it. We know that the interest rate is not equal to, sorry, this one mistake, is not equal to gradient increase. So we will take this formula, not the other one, which is I is equal to G. So I interest rate is 8% and G is 10%. Right? Let me see again. Yeah, the interest rate is 8% and increase gradient increase is 10%. A is 100 and N 5 years. A is $100 and N is 5 years. All right, let's write it down. The present value is 100 multiplied by 1 minus 1 plus 0.1, which is 10%, power of 5, and 1 plus 0.08 minus 5, minus power of minus 5, and I minus G, which is 0.08 minus 0.1. Then let's see what is the answer of this guy. Let me calculate it again. So it's gonna be 100 multiplied by 100 multiplied by, let's take this parenthesis, 1 minus 1, again let's do another parenthesis just in case, 1 minus 1.1 power of 5, 1.1 power of 5 again, and 1.08 power of so it's gonna be, let's do this guy, is multiplied by 1.08 power of minus 5. Alright, let's close this up, this one, and let's say over 0.08 minus 0.1, right? So let's see, is 480.4. 480.4 dollars is the present value of this question, which was the first year maintenance for the $100 if it is given, right? For the 8% interest rate and 10% increased. So normally it was like without increase 5 years is gonna be 100, but like you can think of this one as an inflation. So that's why we are taking present values. Is if you pay like 480, it's gonna be increased, the power of this money or the value of this money is gonna be increased. Let's go through the our textbook. If we can do it in this way, as you see, there is no small g values, so there is no tabular form for geometric gradients. Only we have single payment, uniform payment series, and arithmetic gradients. We can convert it all these other terms to each other, but if we have this geometrically increase, we have to use the mathematical form. All right. The final subject for this week is general workflow. We need to depict. Our goal is what value would be equivalent at some other point in time. So the first step, you need to determine factors. The value to be analyzed is going to be future or present. The equivalent value, like where you want to make it this money to be, present or future. And we need to know the interest rate and the number of periods. After we determined all these factors, we need to solve one of the two ways. The first one is using the single payment formula, which is the mathematical representation I gave you, or using the functional notation version compound interest table, which is I showed lastly in the textbooks behind. All, like, you guys can find it anywhere in the internet as well, or all the engineering economy textbooks you guys can see. And also I will provide for you guys if you guys want. Of course in the exam I will provide you guys as well if necessary. So like after we know where we want to know, and then interest rate and the number of periods, we need to just solve, and we can solve two ways. And also there are three ways. The third way is, but we are not gonna use in this class because it is with using Excel, but it's out of our subject, our scope right now. We are not accountant, we are a civil engineer, so we just need to concentrate on how it works, then we can solve all this stuff. All right, take care. If you have any question, just let me know. Have a good weekend. Take care again.